After spending a lot of time explaining how powerful Turing machines are and how they can basically simulate everything, now we need to see how it works in practice. Now we are asked, construct a Turing machine such that on input x equal 0, 0, 0, 0, y, it outputs y. For example, let's say that here we have the input x equals 0, 0, 1, 0, 1. Then we want to output y equal 1, 0, 1. Just removing the initial zeros. And on input x equal 1, 1, well, y will just be equal to 1, 1. We want to basically get rid of the first zeros. This is a really simple problem, and we can do it really efficiently. And basically, we know that a Turing machine can simulate everything and can simulate algorithms efficiently, because algorithms can be, in a way, just Turing machines with some more details, more tapes, more alphabet, more symbols, and just it doesn't really matter as we saw. And so usually when we say construct a Turing machine, we can equivalently just construct pseudocode or any algorithm that can solve our problem. But here, just to do it once, we'll just use a raw Turing machine just to see how it works. And we can basically choose whatever setup that we want. So here I will say that my Turing machine has access to an input tape and one read and write tape. So we can basically say that k is equal to 1. And so here we will start with this thing that is empty, and here we will have our input. And at the end, for example, if the input is equal to 0, 1, 1, I want that on my tape, I only write 1, 1. And so the idea is that we basically will first read the input, and as long as we just see zeros, we don't do anything and we just continue reading. But as soon as we see a 1, we start copying the bits on the output tape, that is also the working tape. And formally, how to do it? Well, I need to define a set of rules, and the rules will always look like this. Here I say my rule for Q0. I will have something like, if I read something in my input tape and in my working tape, then I should replace the symbol in my working tape because I'm not allowed to write on my input tape, and I should move somewhere. So let's say, for example, left on my input tape and right on my working tape. All the rules will have this shape. And so here, if on my input tape I read nothing, so I'm just at the end of the input, well, I'm basically done. And if the input is empty, I should return something empty. So no matter what I read on the working tape, if I finish reading, then I'm done. So I just replace with nothing on my working tape, and I just say that we can stay, and of course I forgot to say it, but we need to say in which state we will be. And so here I just say that I'm in state QF for final state. And so if I read a 0, well, basically I don't care about what I can read on my working tape because I just need to continue reading. So I will just not write anything on my working tape still. So I will just not write anything. And I should continue to move right. And here I just need to stay on my working tape. And I continue to be in state Q0. But now, as soon as I reach a 1, I need to change my state. I don't need to only read, I need to copy things. So as soon as I read a 1, no matter what I read on the working tape, I need to start to copy. So if it starts with a 1, I need to copy the 1. And I need to move right in both directions. And here I need to move to state Q1 that we'll just define now. The state Q1 basically is just a state where everything that we are reading is going to be copied in the working tape. And so here, Q1, no matter what we read, so let's say if I read a 0, if I read a 1, no matter what I read on the working tape, basically I never read what is on the working tape. I will have to write a 0, a 1 here, and I will have to move right on both tapes. And I will continue to be on state Q1. And when I will reach the end of the input, I will be done again. So if I read nothing, so if I read that we are at the end of the tape, again, no matter what I see on the working tape, well, I will just say that we keep it like this, we can stay, and we move again to the state Q final. And the state Q final, I need to also write the rule. It will be really simple, But in state Q final, we just say that we stop, that we are done, and that the output is what is written on the working tape. And so let's see it with an example. Let's imagine that we have the input tape like this, and we have the working tape like this. That is empty for now. And so here, the input could be 0, 0, 1, 1, 0, and then we have nothing. And so here we also have nothing in all the tape. And the heads are here. I will just write it with an arrow to make it simple. And we start with state Q0. So now, let's start the algorithm. Now I'm reading a 0 and I'm in state Q0. It says that I should just write nothing, so keep like this, move right here, and I should continue to be in state Q0. So now, again, I read a 0. So the same thing happens. I don't write anything in the working tape, and I continue moving right. Okay, but now we see a 1. And we see a 1, it means that we need to replace the symbol that we are reading now in the working tape with a 1. So we remove this X here, and we write 1. And we need to move both heads to the right, and to move to state Q1. So now the heads are here, and we need to move to the state Q1. Here we are again reading a 1, and when we read a 1, we should replace the symbol that we are seeing now on the working tape with a 1 and move right and still be in state Q1. So first we replace this symbol with a 1 and then we move the heads. Now we are here and here. So now we are still in state Q1, and in state Q1 we said that if we read a 0, well, we need to replace the symbol that we are seeing with a 0 and to move right. So you already know how it works. 0 here, and I move right. So I'm here, and I'm here. And now I'm seeing a blank symbol, nothing. And so I should just replace the blank symbol with the blank symbol itself. So nothing happens. And I should stay and reach the state Q final. So now I'm in state Q final. And what it says that I need to stop. And so basically, this is our output. And of course, here, the input X has 0, 0, Y, with Y being equal to 1, 1, 0. And it's indeed what we have here. And so, of course, it's a very simple algorithm, but no matter the algorithm that you wanted to implement, it will be possible to do it with a Turing machine. And of course, if we had more tapes, if we had more things, we could do it differently. But here with our definition, this is how to do it. It works pretty good. And the running time of the Turing machine is at most n steps, because we just need to read everything once, and that's it.